Hello, good afternoon, friends. In the last class, I was discussing Maxwell distribution of velocities, particularly Maxwell Boltzmann equation, and explain the terms in it. What are the terms in that equation? And after that, we studied the interpretation of Maxwell distribution of velocities. That is, there was a graphical study in which the velocity versus probability graphs, three graphs we studied. And after that, I was discussing the effect of temperature on Maxwell distribution of velocities. These all will come under the chapter gases. Okay. In today's class, I was already explaining the most probable velocity. From the graph, you came to know what is most probable velocity. Definition is very important. That is the velocity of a gas at a particular temperature. Most probable velocity is the velocity of the gas at a particular temperature, and it is a velocity possessed by the maximum fraction of total number of molecules at that temperature. I will repeat once again. Most probable velocity is defined as the velocity possessed by the maximum fraction of the total number of molecules at that temperature. So, from the graph, you have to calculate the maximum fraction of the molecules at that temperature, one particular temperature. So, that is the most probable velocity. Most probable velocity is a particular temperature, at a particular temperature is the velocity possessed by the maximum number of molecules. In the graph, you came to know that the middle portion it is a parabolic graph, and if you see the peak of the graph, you will calculate the area at the peak of the graph. That will be the maximum number of molecules possessing maximum fraction of the molecules possessing the velocity. Understood? Again, I request you to just see the notes, just see the graphs, and from the graph, the peak of the graph, if you see the peak of the parabolic graph, you will get maximum fraction of the number of molecules, and that velocity of that particular area is the most probable velocity. So, most probable velocity of a gas at a particular temperature is the velocity possessed by the maximum fraction of the total number. Total number of molecules, suppose 100 molecules. Maximum fraction may be 88 molecules. Understood the point? 88 by 100. So, that is the number that will be having the maximum fraction of the molecules having a velocity. So, that velocity is known as. In the graph, again, I am pointing down that in x-axis you have to take the velocity, and y-axis you will find out the probability of finding the number of molecules. So, there are three types of velocities: most probable velocity, average velocity. Average velocity is you also know. If you take a sample of gas, there are a number of molecules, and if every molecules are having different velocities, you have to add the velocities of those number. That is represented by mu. Most probable velocity is denoted by alpha, and average velocity is represented by eta, not mu. It is eta. So, eta is equal to the velocity of the different molecules. You have to add the different molecules and divide by the number of molecules, just like average. That is arithmetic mean. So, average velocity is the arithmetic mean of the velocities possessed by the different molecule of a gas at a particular temperature. So, you are studying the samples at a different temperature. Okay. At a particular temperature, you have to add the velocities of every gas. Suppose take an example, eta is equal to velocity of first molecule plus velocity of second molecule plus velocity of third molecules plus etc. velocity of the nth molecule divided by n number of molecules. Addition. You had arithmetic means addition. In books, in the book, there is a slight change. They have not given the addition symbol there. Actually, the molecule's velocity should be added. Okay. Suppose each and every molecules will be having different velocities. Each and every molecules having that. Then, if you take one molecule, n number of molecules having a velocity of v1 plus n2 number having a velocity of v2. So, if you take like that, n1 v1 plus n1 v2 plus n1 v3 plus n3 v3 plus etc. Up to n vn divided by n1 plus n2 plus n3. So like that you have to calculate the arithmetic mean. So average velocity is generally it is defined as the arithmetic mean of the velocities possessed by the number of different molecules of a gas at a particular temperature. So that is the arithmetic mean. That is the average velocity. Most probable velocity, that is the velocity of a gas at a particular temperature. It is the velocity possessed by the maximum fraction of the total number of molecules at that temperature. If you find out, I told you how to calculate it. You have to calculate the area under the peak of the graph, which we told you. So the arithmetic mean means average. Average you have to take the average for that. And in the third section, root mean square, RMS velocity. RMS velocity is defined as the square root of the mean of the squares of the different velocities. It is denoted by mu. Mu is known as a root mean square velocity. It is defined as the square root of the mean of the different velocities. Mean of the squares of the. You suppose take an example. I can say mu is equal to square root of the different velocities, that is v1 squared plus v2 squared plus v3 squared plus etc. vn squared divided by n. Square root of. It is the square root of the mean of the squares of the different velocities. Right? Here also you can calculate, you can take different molecules having different velocity, n1 v1. So square root of, in that case, square root of n1 v1 squared plus n2 v2 squared plus n3 v3 squared plus etc. divided by n1 plus n2 plus n3, that you have to calculate. So that is the root. There are three velocities. The definitions are important. Here what you have to study is write down the Maxwell-Boltzmann equation. And he explained the terms in it. And the Maxwell-Boltzmann equation, second 1 by n dot dnc by dc is equal to 4 pi into m by 2 pi rt to the power 3 by 2 into e to the power minus mc squared divided by 2 rt c squared. So actually you have to calculate, you have to explain the terms in it. M molecular weight, RT, you know it because universal gas constant and absolute temperature, pi value go to. So mc squared, c is the velocity. Okay, so like that. The dc is a small fraction you have to calculate, a change in velocity. So these all I told you in the last class. Similarly, the other section you have to study is the graphical study, and what do you mean by most probable velocity, average velocity, and root mean square velocity. How to calculate it mathematically, that is the thing you have to study in your session. Again you have to study the derivation of the most probable velocity from Maxwell-Boltzmann equation. Only velocity, that means most probable velocity derivation only you have to study. You need not study the other two velocities derivations. Only you have to study the definitions, not the derivations. But in the case of most probable velocity, how to find out the most probable velocity from Maxwell-Boltzmann equation. So if you want to write that very easily, you write the Maxwell-Boltzmann equation. The result is obtained by differentiating the right side of the equation. Right side of the equation, if you differentiate with respect to C and equating the result as 0. So you will be getting the right side, right side of the equation, right, Maxwell-Boltzmann equation. If you differentiate with respect to C and equating to 0, then it is 1 minus mc squared by 2 RT into C e to the power mc squared by 2 RT. Right side. So that is equal to 0. So actually if you rearrange that, C is equal to square root of 2 RT by m. C is equal to square root of C RT by m. C is nothing but most probable velocity in that case. C is equal to square root of 2 RT by m, representing the most probable velocity by alpha in place of C. So C, you can take it as alpha. So in that case, alpha is equal to square root of 2 RT by m. So in Maxwell-Boltzmann equation, you have to write the equation and differentiating the right side of the equation, and you will be getting the fraction like this, 1 minus mc squared by term like this, mc squared divided by 2 RT bracket into C into E to the power minus mc squared by 2 RT. That is equal to 0. Calculate model. And if you do the further rearranging that term, you will be getting C is equal to square root of 2 RT by m. So that is most probable velocity. That should be taken as alpha. In the case of average velocity and root mean square velocity, I told you there is no need to derive the equation. You should study the value, that is eta is equal to square root of 8 RT by pi m. Square root of 8 RT. That also you can be derived from Maxwell-Boltzmann law equation, but it is not necessary for that. That is square root of 8 RT by pi m. That is equal to average velocity. RMS velocity is equal to, that is mu is equal to square root of 3 RT by m. So in 3 equation you have to remember. The first equation, C is equal to square root of 2 RT. That is equal to alpha. Alpha is equal to square root of 2 RT by m. That is known as most probable velocity. That can be obtained from Maxwell-Boltzmann equation. And second one is average velocity. Average velocity, its value is that is eta is equal to square root of 8 RT by pi m. Okay. And in third one is mu, that is root mean square velocity, that is square root of 3 RT by m. First definition for all these velocities and then equations for all these velocities. And then it is given in the syllabus, what is the relation between these three? So you have to write all 3 equations, and first you have to do the first equation divided by the third equation. First equation divided by the third equation, you will be getting alpha is equal to first equation divided by the third equation, and then you have to do the simple calculation, and you will get the value. Alpha is equal to 0.816 mu. Alpha is equal to 0.816 mu. That pi value and 8 value, these all we have to evaluate, and finally the value will be alpha is equal to 0.816 mu. And similarly, the combining, that means second equation and third equation, if you combine second equation divided by the third equation, you will be getting eta is equal to 0.921 mu. So the relationship you will be getting the relationship, the values. Alpha is equal to and alpha is to eta is to mu, right? If you write the ratio like that, and if you write the equation, square root of 2 RT by m is to square root of 8 RT by pi m is to square root of 3 RT by m. So if you take the ratio of like that, the value will be square root of 2 is to square root of 8 by pi is to square root of 3. So it is given in the notes. You can see the notes, and you can do the calculation also. And final value, the ratio will be 1 is to 1.128 is to 1.224. That is alpha is to eta is to mu. 1 is to 1.128 is to 1.224. By using this, you can do certain calculations and small problems and all. So in this particular chapter, we are dealing with some calculations and some derivations. There is not much derivations. Only one derivation is the small derivation is there. That is the derivation of the most probable velocity from Maxwell-Boltzmann equation. That also for only two steps. Those who are not particularly CBSS students and CSS students, CBS students, that is the biological science students, I think they cannot understand so easily the differentiation and integration, etc. They should study the value. They should study the value. You write the equation and taking the right side of the equation, differentiating the right side of the equation, and you are getting the value 1 minus mc square by 2rt bracket into c e to the power mc square by 2rt. So like that term you have to study. Then only you can produce at the examination. So that thing you have to keep in your mind. Students, there are certain problems, and these problems we will do only in the class, not in online classes. Whenever we see, again, we will study those problems. Students, there are 3 more definitions: collision diameter, collision number, collision frequency, and mean free path. So these 4 definitions I have posted you in your group. So that also you have to study. What is collision diameter? Collision diameter symbol is sigma. So that is the distance between 2 centers of the molecules at the point of closest approach. So collision is in between 2 molecules, 2 identical molecules, and the centers, the distance between 2 centers of that molecules is not taken as sigma. So that is collision diameter. Collision number is the number of molecules with which a single molecule will collide per unit time and per unit volume of the gas. That is collision number. Number of molecules with which a single molecule will collide. Particularly if you take a second of 1 centimeter cube. So 1 centimeter cube you can take, 1 second you can take, right? So if you take that volume of a gas, number of collisions a single molecule will collide with other molecule. A single molecule will collide with other molecule. That is collision number. And for those, equation is Z1 is equal to square root of 2 into pi sigma squared C dash P, rho, not P, rho. That is Z1 is the collision number, sigma is the diameter of the molecule, C dash is the average velocity, and rho is the number of molecules per unit volume of the gas. Similarly, what is collision frequency? That is the number of molecular collisions occurring per unit time, per unit volume of the gas. Actually, what I told collision number is only for one molecule. Collision frequency is the number of molecular collisions occurring per unit time. For every molecule we are calculating, that is suppose 2 molecules, Z11, that equation is a slight difference is there, a rho squared, that is 1 by 2 into square root of 2 pi sigma squared C dash rho squared. So these equations are important, and mathematically. Mean free path also you study. It is defined as the mean distance travelled by a gas molecule between 2 successive collisions. So after collisions, the mean distance travelled by a gas molecule, that is also given, and its equation is also given in the notes. So dear students, you have to see the notes and you have to listen me, and you try to study the most important thing, not the unimportant thing, the different definitions, and the most importantly the the derivation, slight derivation, and graphical studies and all. and we will again meet you in the next class. Thank you very much for listening me. Keep on watching the YouTube in your mobile phone. That is SSFGC Chemistry. That is our password. You just open it and you can see the classes and listen to the classes and see the notes. That is very important. Thank you very much.